I'm Marcelo Wanderley, and I'm Associate Director for Science and Technology at CIRMMT. I'm responsible for the second research axis or theme in CIRMMT called Musical Gestures, Devices and Motion Capture. And the idea actually is to study ways to, for instance, develop new musical instruments using the computer, so devices. These devices may be similar to acoustic instruments that we know, or totally different. It could be, for instance, people dancing and creating music. That's not so new, but I mean, we have different ways of doing that. Or devices specialized in some applications. For instance, one of the projects we have with the Montreal Neurological Institute and with Concordia University, so 3 researchers, it's on developing instruments, musical instruments that can be played inside magnetic resonance machines. So they cannot contain any type of metal that could be magnetized, so otherwise it would become really a gigantic magnet, or it would be taken into the machine. So we have to design these instruments by creating new sensing technologies that avoid using materials that could affect the machine.
I'm working with Marcelo Wanderley from McGill and Virginia Pentune at Concordia University in the neuropsychology department. And with them I'm developing an fMRI compatible piano keyboard that will be used in neuropsych testing of how people learn how to play musical instruments and coordinate their movements in order to do so.
We are also interested in devices called force or tactile feedback, so devices that can actually output forces or vibration, so that people with disabilities, for instance, they could feel what's going on without needing to see something, for instance, a blind person. But also this can help performance. So in musical instruments, people usually rely on vibrations and, for instance, read vibrations. So we can simulate this kind of behaviors using computer-generated sound. So this is a project basically led by Professor Hayward in electrical engineering at McGill, so a specialist in tactile feedback devices. We also do a lot of work on motion capture, and that's basically one of the most important areas in this axis. That's motion capture is used in different types of trackers or systems to measure specific positions of, let's say, body parts in space, in 3D, or sometimes in 6 degrees of freedom, like rotation and translation. So we have several systems, and we are applying for completing and getting let's say, 24 camera systems now in Brahms. And these systems allow for this very accurate measurement. So in one case, we measure how people perform, let's say a clarinet, and how they move when they perform. So for instance, we can calculate the weight transfer while the performance. And then we can look at this weight transfer variation, whether there is any relationship to the music being played. In another project, using similar system, we have researcher Isabelle Cossette from the Schulich School of Music. And she is interested in understanding exactly how people breathe when they play flute. And this is a very hard task because you can't add sensors to the flute, so otherwise you will change the sound. Or you can't really add sensors to the performer because it's not natural to play with something in your mouth. So the idea is to put these markers around the torso of a person and then reconstruct the volume of the lungs while the performance takes place. So she uses around 70 markers placed around the body, and she has 9 cameras, infrared cameras around. And then she can, by software, reconstruct exactly how the lungs are working. And that's a non-intrusive way of calculating these volumes. Right? And this is a very cutting-edge sort of research. I mean, and these systems are fairly accurate. It's the same system that people use for animation and movies.
What is very nice with this system, as Marcelo was mentioning, is that it's not invasive. Before, to know about the volume and the flow used during flute playing was a very difficult task, because the opening of the flute, you're blowing some air here, but there is some going out there, so there's no way to measure exactly all the air that you're using. By using this device, you can have a very precise measurement of all the air you're using while playing the flute.
And the musical gestures part of the axis, that's really understanding physical or musical, really, gestures that performers do by in that case even composers. How does someone play an instrument, whether these movements will be repetitive when people play multiple times, how to understand the different strategies by different performance, etc. And of course, applications are always, or most of the time, to create new instruments using the computer or to adapt sensors to acoustic instruments. What is interesting on this axis in CIRMMT in general is that it allows for this bridge between or among several individual projects that could be done ideally or inside laboratories or departments. But CIRMMT allows us to put all this together and then get a global picture of from respiration to mechanics of fingers to gestures to brain imaging. So I think this is unique, and I think this is it's a very emblematic thing. Indeed, we are organizing now the first workshop on motion capture of music performance, and the idea is to discuss really what can be used, how motion capture can be used to help us understand performance.
Obviously, this research is really multidisciplinary, and I'm always involved in working with other people from biomechanics or from respiratory physiology. I'm working with physicians, from an engineer, and also there's an acoustical aspect to that research, and also, in fact, it applies also to education, teaching music, and so it's really multidisciplinary research, and I must say that I'm not doing all that by myself. I have to thank all other people, and I'm working with people in Italy from different backgrounds.